Hello students, and welcome to another video. Today we're going to be talking about predicting the formation of a precipitate. And I've created this sheet for you. I've shown it several times in the other videos. And it's going to look something like this, the solubility rules for ionic compounds. Okay. And what I've done with this chart that I made myself is I've included what these ions are. Because in the book, it just says salts of alkali metals and ammonia. Well, it's helpful if you can actually see those to help remind you what they look like. So this sheet's a little more comprehensive. You can see a little bit more of what it is that these compounds are, because it just kind of lists them: nitrate salts, chlorate salts. All right, and when it says soluble, okay, it's referring to that if this metal is combined with another compound, it's going to be soluble, except when it's with lithium. Nitrate salts and chlorate salts will be soluble, meaning they'll stay aqueous in a solution with very few exceptions, okay? Sulfate salts, okay? I'll use this paper here to explain it because you can actually see what they look like, okay? You may have recognized nitrate. We've used that several times. It's basically always soluble, so you can just suppose that nitrate is going to be soluble. Sulfate salts are soluble except when they're combined with these substances. So when we're trying to make a prediction, if something is going to be soluble or not, we got to look at what the part is and if it matches with the exceptions, okay? Chloride with these exceptions here, and then we've got these basically insoluble substances. So if you see carbonates, phosphates, chromates, sulfides, and hydroxides, you can basically assume that they're going to be insoluble except when they're mixed with alkali metals. And this chart, you don't need to memorize it. It's just something that you need to be familiar with, and it will always be available to you in my class so that you can work with it, okay? Now, if we come down here, let's make a prediction. We have a complete ionic equation for sodium, carbonate, barium, and nitrate. And we're going to make a prediction which of these possible outcomes is going to be soluble or not. So sodium carbonate and barium nitrate, we're going to switch the positive ions. So it's going to be barium carbonate and sodium nitrate, okay? The positive ions, typically metals, because the metals are the ones that give electrons. I say typically because ammonia is our one example. You got to keep in mind, ammonia is the only positive polyatomic ion. The rest of the polyatomic ions that we're going to be working with are negative. And barium is going to work with carbonate, and sodium is going to work with nitrate. Now, if we look at this, like I was saying earlier, oh, there's a nitrate right there. That's going to tell you that's probably, this is going to be the one that stays in solution. And carbonate, what we know about carbonate is that it's part of this insoluble list. So it's definitely going to be the one that will fall out of solution and be a solid precipitate. And if we look at it, it says compounds of alkali metals and ammonia. Well, barium is not an alkali metal. It's an alkali earth metal. It belongs to family 2, not family 1, okay? And then we look at sodium and nitrate. Again, we'll just kind of beat it across the head here. We have Na and NO3, and they're both soluble. They're both going to work out, okay? So when you're looking at these problems, we're just trying to make predictions, and use your chart to figure out which one of these is going to fall out of solution and which will stay in solution. And all you're doing to set this up is to switch the positive ions, okay? And when we're writing our net ionic equation, we're going to include the barium with the carbonate, and they're going to give 2 electrons, it's going to receive 2, so it's going to form a ionic bond, and it's going to fall out of solution because the barium and carbonate form a strong enough bond to overcome that solvation shell, as we talked about in the previous video, to fall out of solution, okay? Thanks for watching.